So the title of my class is the first step towards 6G, how to bridge multiplayer ecosystem through unified standardization process. So in this title, there are a few keywords. First, we're talking about 3GPP, talking about standardization, and we call this the first step towards 6G. Why this is the first step, and then how, and here multiplayer ecosystem. So multiplayer ecosystem is another keywords. In this class, we are going to give you an overview of this multiple player ecosystem and through the unified standardization process. You're going to understand why standardization is the first step towards the new generation. And then we're going to also go over how all these complicated process is necessary to bridge all the players within this ecosystem. So here is the outline, but we will go through these and the storyline will be clear as we go. But thanks for Professor Wang already give me a very good introduction. So like Dr. Wang already said, I have a few experience in industry, mainly in Qualcomm. So actually, my department is product development department. So we'll start as a modern system design engineer. And then a few years after that, I took an additional assignment as a 3GPP rank working group for delegate for Qualcomm, meaning representing Qualcomm in the 3GPP meetings. And last year, I come back to NTU as an assistant professor. So the modern system design part, of course, that's part of the product development. And today's topic is 3GPP, but how the product develop and how it interact with the standardization process is also one important perspective, because that's help us to understand what's the player rule and the player background inside this standardization process, how it works, and then we can imagine, and easier for me to explain how these negotiation and all the politics or all the competition works in the standardization process. Okay, so I'm going to start with my experience in product development, basically modern system developer. So for us in a school, no matter it's master or PhD program, we focus on technology, and we usually work in the very advanced setting. So we want to explore the frontier of the technology and how we can proceed in the next 10 or 20 years. But what product development focus on is what's the current technology and how do we push those technologies from the paperwork, simulation, or like big FPGA or other programmable device demos into a real system and real device that's in everyone's hand, that's cell phone or around us, for example, vehicles and a laptop and all the devices. So that's the job for product development. And then how the product development process works is the first thing I want to discuss. And the relationship between these product development and standard development, which is our topics today, is that these two have to link to each other nicely so that you can have a standards goes out, and then you can have the standard compliant product in the market for people to purchase and for the service to run on it. Okay, so what do our team do? the modern system engineer is responsible for modern architecture, algorithm, feature design for the latest modern, and lead the coordination of modern hardware, firmware, software team, and implementation and commercialization. Okay, so modern architecture, algorithm, and feature design. So basically, you can see in the market nowadays, it's every year we'll have a new model of cell phone for different brands. You can have Apple also release product yearly, and Samsung, Vivo, Oppo, Xiaomi, almost all the major brands have new product every year. So when you have a new cell phone, you probably can see fancy camera features added, but actually modern, every year we also have some advancement. And the chip vendors, meaning like Qualcomm or MediaTek, need to provide the new version of modems to these OEMs, basically cell phone manufacturer and the brand owners. So the thing is, then what's new in the cell phone chip, modern chip in every year, every new release? So basically, we're going to receive feedback and request from all the OEMs and even operators, saying that last year what stuffs can be enhanced, what's their testing and user experience look like, and then we will have some internal study and review of what's going on and what do we see in the previous generations of a product. So all these like are between different players, but one very important thing is we need to look at the new standards. And as we go, we're going to explain that although we see 4G, 5G, 6G happens like about every 10 years, but in fact, the generation is like a big jump. But between all these big jump, we have many small leaps in between that. So that's why standard keep evolving every year, and modern product have to catch on the standards and develop new features for every new release. That's basically how standardization and product development interact with each other and work together, so that when you get new product every year, when you purchase a new phone, it's actually really new, not only from the camera perspective, which you probably can easier understand because it's just like more pixels and probably more better lenses, but in fact modern also evolve every year. Okay, so that's how the architecture, algorithm, and feature design, the new stuff coming from. But then once you have all these system design, then we need to implement it, because when we say system design, it's actually paperwork or even like simulators, like it doesn't really exist physically. So how do we turn this into like actual physical product? The first thing is everything is on the chip, so we need the circuit design team, and what we want, what we design, what's the new feature works, how the algorithm works, we need to coordinate with the hardware team so that they can design the circuit, actually serve this functionality and execute what the algorithms will design for. And then on top of hardware, we need firmware and software to drive all these features. So we also have dedicated firmware and software team to implement all the features designed by the system team in different functional blocks. And then one important steps towards the actual commercialization is testing, because what we design for is what we expect the device to work or the chip to work, but how it actually works, we need to test it to verify whether it's as function and work as we design. And these testing since we're discussing standardization, so it's actually not only just test the chip itself, it's a very important perspective. You guys probably won't be familiar. Is the interoperability perspective. That's the very important part of testing, and that's essentially coupled with the standardization. What is interoperability? Basically, it's the ability to have your chip on one side and operate with the other side of from different brands. For example, Qualcomm's chip, when we do the testing, first we want to make sure that internally this chip work by itself, connect with different like simulations and different test platform, it works. And then not only this, because I need to make sure that no matter I connect with Ericsson's base station, Nokia space station, Huawei space station, or ZT space station, all of this connection works, because that is what my product will going to see when it's really on the field. You cannot choose which brand or of base station you're connecting to, right? Because when I get to a new area, I never know whether this base station is a Huawei base station, Ericsson base station, or Nokia base station. And remember, standardization is basically a standardized interface, so that makes sure the interconnectivity is guaranteed. We'll get a little bit deeper into that later. But basically, you can see standardization is for interoperability. So testing needs to also cover interoperability part. Make sure that everyone follows the standards, and when it follows the standards, everything connected and works. Okay, so that's basically how the product through these. I mean, what I'm talking about is my working experience in Qualcomm, but based on my understanding, most of the companies that work for cellular technologies are have similar structures, and basically this is how product and development and standardization interact with each other. Okay, so a little bit about what I actually do in the modern system engineer. I have worked on, I sampled two interesting projects. One is power efficient receiver antenna controller. So basically that determines how the antenna in your cell phone works, meaning how many which antenna I'm going to use right now and how many antennas I'm going to do. So I picked this functionality because this is one example that because this is an interesting one. So initially in Qualcomm, developed it as like internal feature. So I don't want to go into the details of how this works, because that's a proprietary information. However, in the that's during the LTE days. However, in NR, meaning 5G, standard site is actually develop a similar concept through some protocols, allow the base station and UE to coordinate through this protocol, so that UE can better choose which antenna and how many antenna they're going to use when implement. So many features in the cell phone or base station, when it's standardized with information exchange, sometimes it can enhance the performance of some like one-sided based algorithm. Okay, MU-MIMO receiver is another example, and this is basically I developed the MU-MIMO receiver for Qualcomm's product, but I also work on the MU-MIMO specification. So my work in this project is actually demonstrate that how product can affect by standards, because when you develop product, for example, the receiver actually finds some information that's needed from the other side, meaning I'm developing UE, so it's a base station information that I want to try to acquire. And however, whenever you need to acquire any information, that requires a standardized interface, that requires a protocol, and then standardization procedure and standard meetings can provide a platform for companies based on their product development or product planning, that which information, which procedure you envision, you can actually try to propose and get this proposal or this procedure signaling agreed in a standard. So when it becomes standards, then your algorithm will become more useful. That's one of the example of the how the product and development and standardization interact. Okay. So how does this like everything works in the modern development? And I'll go into more details on how it interact with the standardization process. So mobile communication network is a very complex system with multiple players interacting with each other. Standard organization, operator, infrastructure, vendors, chip vendors, and OEMs. Okay, so remember I was saying that one of the key word is complex ecosystem with multiple players. And then this is a multiple player ecosystem. However, each player needs to come up with their product roadmap. Product roadmap refers to the plan of releasing different product. And when we start to develop and when we can have this product ready, and when we ship to customers, when these devices carry those chips will be in the market and in the network. Okay. However, if every player make their product roadmap by itself on its own, then can you guys imagine what can happen? Imagine that your cell phone have some functionalities that when you got the new, it's in it when we got the new cell phone. However, when you turn on your cell phone and be in the whatever network you guys are connecting to, probably Zhonghua, probably Far East Tone or other operators. But what you find out is that they claim this new communication feature. Of course, usually communication feature is not available to the I mean, not visible for ordinary customers, but you guys are communication engineer. Imagine that you have a feature that promised by the cell phone company saying that we're supporting this feature. However, when you be in the field, you find that almost no base station support this feature. Is this feature useful? Of course, it's not, because communication is a two-sided operation, and each of these sides need to support the feature so that everything put together can work. One side ready and supported doesn't mean this function is usable. Okay, so this is an ecosystem, and everyone has to be ready so that the a feature or new functionality can be seen and used in the real network. So everyone's product map is actually the first base is the standard releasing timeline. Basically, standard releasing, meaning the standard ready becomes a signal or the kind of like primary requirement for all the features to be start implementing and maybe launch in the market. And then if everyone follows the develop their product roadmap based on the standard release timeline, then it's easier for the companies to coordinate with each other, because you now have a reference of develop timeline. So basically, standards, if standard is ready at this point, and then how much time do I need to develop these feature and put them into my new product, and when I can launch the product with these new features. And because everyone use the standard release timeline as the basis for organizing and planning their product maps. So when you want to align different companies, different players, that becomes easier stuff. And of course, not standard timeline is not everything, because not necessarily every features developed in standard is actually implemented. And also there are a lot of different implementations, enhancement that's compatible with new standards, but don't compatible with old standards, but doesn't read new standards. So these are like customer demand. For example, chip vendor can get some ask from OEMs, and then operators can ask infra vendors to make some other enhancement. So these are also can affect the product roadmap. And then the other thing is, what is the communication for? Communication itself doesn't really create value. It's the applications and the services running on the communication network that can create the values. So looking at what is the service running now, and what additionally we can do as from the communication network perspective to enhance the user experience of the applications and services, that's also an important factor contribute to the product roadmap. And then readiness of the ecosystem, meaning everything to be ready, including infrastructure, including the devices and the apps running on it, and the operators setting all this up and turning on these features. So that's also that requires collaboration across all the ecosystem on top of following the standard release timeline. So all these are contribute to product map. Okay, so now we're in the planning stage, and then after the planning stage, what's the next? So basically that's system design and implementation. So now we have a set of goals and the features we are targeting from the product planning and roadmap and the roadmap development. And then we need to design the system to implement all these features, enhancement, and probably new functionalities provided by new standards. Okay, so we start the design stage based on the input from the ecosystem, which is go through product management, internal development. That's what we learned from the previous modems. And then customer feedback. That's what we discuss information from the roadmap. And based on all these, do we need to update our system architecture? That's the first thing we need to decide, because system architecture is before everything. And then on top of this system architecture, what are the new features and the new enhancement we're going to build on these system architectures? So basically that's the main design and the main component update or functionality update for these generations modem. Okay, so of course this is pretty aligned to what we are working on in PhD or master program. So basically, we have specific communication problems or specific communication algorithms to be designed based on the based on the demand from product roadmap, meaning ecosystem, internal development, customer feedback act. So then we need to define the problem clearly, and we need to find an algorithm, design an algorithm to either resolve the issue or fulfill the functionality and the requirement. And then we do what our system engineering is doing. We basically have a simulator which emulates the product and put new algorithms on this simulation platform, so we can at least from simulation perspective, from analytical perspective, understand what do we expect from these new features when we add to our platform. Okay, so that's the design stage, which you guys are probably more familiar with. And then the next stage is very important, that's implementation. So basically, based on all these, we have hardware team, firmware team, software team, and we need to communicate all these with them. We have our plan to develop, but these teams, they need to feedback to us whether this design is feasible or not. For example, is it too costly? Can we fit what the required functionalities into the target chip size? Because chip size basically is proportional with the cost of the chip. Okay, and what can affect the chip size? Basically, how many logic gate you use, and how many logic gate you use, you can derive it from your algorithm analysis. How many multiplications, how many additions, and how many data movement, and those things you're doing. And then the other big chunk of the area is memory. How much memory do you use? And that's related to what's the operation you're using, or what's the precision requirements you're going to use in your algorithms. The more precise you are, the more bits required to represent all these numbers, and all these affect the memory size. And of course, if you're looking for larger throughput, then that means you need to process more bits at the same time. That also affect your cache and memory size. All these things can affect hardware design. So when we interact with hardware team, it's not like a one directional communication. It's actually bi-directional, because we want to give them our design that feedback based on what required from circuit perspective to implement these algorithms, and then whether that's fit their requirement or not. If they don't, then we need to negotiate how we achieve the common goal of releasing a new product that's cost efficient and also with good performance. And similarly with firmware team and software team. And then testing is basically because we design all the features. So we understand the feature, and then we know only us can deliver a complete plan of how to test these features, because we know what to expect and where these features should work better, and whether there's any weakness of the features. So testing plans we need to come up with, and then as testing to do it. So design verification, of course, that's a very important procedure, because human can make error. So we need to have a complete procedure to capture any error we make during this design process or even implementation process by all these things. Testing commercialization process, that's very important, because for hardware business, it's a little bit different from software business, because software you can provide patch or update after you release your product. However, how do you update your hardware? The only thing is recall the product and give you a new one, and that is impossible for a cell phone, because what you recall is not the chip itself. You need to recall all the cell phone. So this is just impossible to happen. So these testing process and design verification process will have to be super careful, so that everything we deliver to the customer in your cell phone has to be reliably functionally well. Okay, so that's enough for product, and that's a kind of like precursor for the discussion on standards. So now we'll get to standard part. My experience is in Qualcomm is 3GPP working group 4, and my job and my objective of participating in the meeting is align the product design and performance with the specifications, because every delegate works for their company, and especially for Qualcomm, we have product. So our main and key interest is whether the product align with the specification, or whether the specification provide us a good space to work and develop the product based on our existing company implementation structure. And of course, Qualcomm has another very important interest is the licensing business. We'll get to that later. Okay, so, and if you look at the text more carefully, you can see RAN working group 4. Okay, so what is RAN? RAN is radio access network, basically the interface between the base station and the UE. Group 4, that means you have several groups. So because the specification work is like the amount of work is very large, so we actually divided into according to what specification we're working on. We divided them into different working groups. So we divided them according to first communication layers. So RAN working group 1 work on the physical layer, and RAN 2 works on the MAC layer or above, and RAN 3 mostly works on the network layer functionalities that interface with the core network. And then working group 4 works on the test and requirement procedures and measurement related procedures for the radio resource management functionalities. So we'll get to those working groups later, but all these working groups, although they are have their meetings in different meeting rooms, and then they consider as different working groups. However, these working groups have to be, the result produced from each working groups has to align with each other, so that when we put everything together, it becomes a workable system. Otherwise, if your physical layer design is contradict with your upper layer design, or your the requirement we set is not feasible for the physical layer procedures the other working group design, then when we put everything together, nothing can really work. Okay, so from standard meetings perspective, we need to coordinate. All the working group has to be consistent. So for company internally, we need also to coordinate with other RAN working groups, delegate internally with the within the company, so that Qualcomm delegate team as representing Qualcomm's team can have very consistent proposals across all the working groups, and this also increase the chance for us to pushing through, because that is a comprehensive system implementation and protocol. So it won't contradict with each other. Okay, so the last thing is we need to push Qualcomm invention with better system performance into standards. And so the project I'm working on is standardization of AI ML interface. So of course, this is very important for 6G, and then I also continue work on these after I joined NTU. And other project, I think let's get into the 3GP part faster. So I'll skip the other project. Okay, so why do we need standards? Like I already said, interoperability is the first thing, because we want to make sure that the system can work when devices and network infrastructure follows specification, no matter who implement the product. Imagine that you have several chip vendors producing and design cell phone chips. You have Qualcomm, you have MTK, and you have HiSilicon, which is part of Huawei. And Samsung, sometimes they also design some of their product is based on from their own chip design. And then from infrastructure side, as I already said, mentioned, Nokia, Ericsson, Huawei, and ZTE are all different infra vendors. So at least you have 4 or 5 infra vendors, and you have 4 or 5 chip vendors. And then if what we want to make sure is all the different combinations, it could be range from 16 different combinations to 25 different connections between these players. And how do we make sure that every connections is feasible and workable? That's why we need a standardization standardized interface. Okay, so that's a concept. However, what's tricky is what needs to be standardized and what can be left for implementation, because you also don't want to specify everything from transmitter all the way to from the starting of the transmitter chain, and then all the way to the radio component, also a receiver, all the way from radio component to the end of receiver chain. Because if you standardized everything, everyone follow standard, then this is essentially, you can say, monopoly or nothing left to be designed. However, we are in a capitalism society, so we have market and we want to encourage competition. How do we encourage competition? Our standards needs to be cover enough interface and design details so that everything follow these standards. When we connect them together, they can work. However, under this constraint, we want to maximize the space for each company to implement their own algorithms. So, a very important trade-off and discussion is what to specify and what not specify, so that company can implement their own stuffs. Okay. And of course, the same questions may have different answers from different players' perspective, because the more stuff you standardized, then the easier the operation is. But if you don't standardize some stuffs and you allow implementation, different implementations, and then the other side, you need to accommodate all these implementations. So that's why these sounds like a question with a standardized standardized answers, but it's not. It's actually different player may have different perspectives, because whether you specify this or not, sometimes both are feasible, meaning with standards or without standardization of some specific protocols or functionalities. However, if you don't standardize that, then the other side probably have to accommodate more, a little bit more different behaviors. Okay. Another perspective is when you are operators, then you also want to look at the standards to understand a few things. So basically, because you need to figure out your deployment plan. For example, the most important question is, how many base station you are going to put in a specific area. But how do you determine that? How many base station to put in the area depends on how much area, how large the area, the size one base station can cover. Okay. However, we have different brands and different brands of base station infra vendors: Ericsson, Nokia, Huawei, and ZTE. So if they all have very different cell coverage, then the planning become very complicated unless you all buy the same brands. But actually, operator have the want to maintain the flexibility of cover different using different brands. Then what happen? What can make their life easier is I standardized a few key parameters that can help the operators to plan for the cell coverage. So, and actually this is not only the base station problem, because base station is a transmitter for downlink, a receiver for uplink. However, device is also the operator for is also the receiver for downlink and transmitter for uplink. Okay, so if you add UE brand in, that's also a very different another very important factor. And what you end up getting is you also want these UEs to perform well enough so that within the designed coverage you have, all the UEs has to be satisfied with satisfied performance. Because when you are what happens is when your cell phone has very bad coverage or very bad signal, sometimes you mostly complain the operators instead of your cell phone. Okay, so that's why we also have performance requirement with different signal strength for the devices. So meaning every devices, when you want to commercialize them, it has to satisfy a few performance requirements, so that when you are in the network, then within the planned coverage of your operators, you can have signal. You can have pretty good signal. And of course, operators, it's not necessary that they want to have a base station there, then they can have a base station there. That's depends on the cost and availability of putting a base station in that area. But standardized in the specification, we do provide such parameters that they can plan the base station deployment accordingly. Okay, so 3GPP introduction. So 3GPP work based on participation in face-to-face meeting and proactivity contributions. So we need to have written proposals contribute to the meetings, and then in the meetings we're going to go through these proposals to decide what to specify. Okay, and we have 3GPP decision is consensus driven, meaning all the decision we are looking for is the agreement without sustained objections. So why we decided like this? Why don't we do majority rule vote to decide everything, which is much faster? I'll get to that later. Then how do 3GPP organize its works? So first we have study items, meaning if any new and big things come up, we first study it, and then we have work item, meaning based on the study result, we turn them into specification. So, but not everything we need to study, only the newer things, newer concept, or bigger things. For example, the 6G because it's new generation. So we have 6 study items. Basically, we want to study and discuss what are the potential enhancement we want to have in 6G. So this is a study item started in August this year, and then it will continue until the end of 2026. So we have a big picture of what to be in the 6G and have a brief ideas of how much benefit it can bring us. Okay, so the work item stage, which usually after study items, if there's is and study item, is the real specification, meaning the outcome of the work item is a real specification, standardized process that all the companies can implement based on the specification. And in contract, study items, what they produce is not real specification, is the directions and the scope of the work items after that study item. Okay, and releases with fixed timeline, which are partially overlapping. So basically, we have a fixed timeline to deliver the new version. Here, release you can consider as a new versions of the standards. And if it's, for example, if it's getting close to 6G, then we will have a major first release for 6G. That's a really big change. But even after this first version of 6G, we'll keep updating 6Gs every year and a half or two, so that our standards can catch up with what's needed in the market for delivering all the different services, which is keep evolving, because the demand may not come as sparse as like 10 years. It's new stuff, new items, new stuffs, new features, and new services comes up probably every year, and we are trying to use this release timeline to address it. Okay, and we have 3 stages in the standard discussion. It's usually overlapping, and it's basically determines what to discuss and how do we specify and what is specified. Stage 1 requirement is basically what's the discussed, meaning what are the requested from operators and from the current environments of different services. What's their, because communication is like a structure. Communication itself, again, is not doing any like visible valuable thing for us. It's the service and the devices that's running on the communication work that create value. So the stage 1 is to look at what are the services we try to we try to connect, or what are the communication quality or communication requirement we need to deliver to support the services or the new devices there. So that's a stage 1. And then stage 2 is what's the architecture of the specification, meaning if we want to fulfill such a requirement services, and which layer need to be updated, which functionality we need to add. And then finally is under this architecture of specification, then we can get to protocols, which actually design the protocols. So I think we can stop here, and then after 10 minutes, I'll start from the right hand side.